Good afternoon, everyone, and thanks for joining this session. So, as I made in the last session pretty clear that the intent here is seeing cloud from networking point of view, and that is what we are doing. So, what we are covering, right, as a part of today's session is that, first of all, networking is networking, right? Whether it's in cloud or somewhere else, you are designing service provider network. You're designing your enterprise. Networking is going to be remain same, right? And that's what here also means. If you want to understand what are the various constructs of networking we can find in the cloud, things are same, right? We will be seeing firewall there. We will be seeing subnetworks there. Then internet gateway, NAT gateway, everything is going to be there. But believe me, it is going to be good if you know all these things in advance. And that's why I was mentioning that if you can see the routing and switching part of my my website, right, on the SharePoint, you will be good to go if you are new to the networking. But still, for the sake of this discussion, I will be guiding you all these things in starting few minutes of this session, right? And the intent is that we should all be on the same page with respect to respecting that. And believe me, this enterprise network, whatever we are working on right now, is kind of same in the cloud also, but the terminology is different, right? And their way of implementation is different. But the common thing remains same. If they need, basically, if a particular host wants to reach to different host in a different network, then there must be somebody who is doing this routing, right? And that is router, what we have. So first of all, we will be discussing how the networking we have, right? How we find networking in our current enterprise network, and then we will try to compare that with the cloud. Then the second thing is going to be really important, because I see multiple people have always a problem with respect to this regions and zones in cloud, right? I'm not going specific with respect to a particular cloud. Regions and zones you can find in any cloud like GCP, Azure, AWS, right? Understanding what actually these are and what purpose it is solving is important, right? So we will be discussing region and zones in cloud, and I will encourage you. It means if anything doesn't make sense, just type your question, right? You do not raise your hand, but type your question, and Punish will make sure that it will reach out to me whenever I take a break in this presentation. Okay. The third thing is we will begin with our cloud networking journey from creating your own private network in cloud. Right. Again, the term is different with respect to different cloud, but we will be considering everything as a general approach, right? So we are just making sure that we are creating our own private network into the cloud. Then, what are the public and private networks in cloud? Again, the topology. Sorry, the term is different. It is not related to what we are used to. For example, for us, the public address range is, you all know, right? Which is anything but private, means 10, 172, and 198. And of course, there are subnetwork associated with them, but here the definition is slightly different. So we will be looking deeper into that what are the public and private networks in cloud? Then why do we need internet gateway, NAT gateway, and other things? And whether these are the physical devices or you can spin them on your own, right? The next thing is we would be discussing about how we can introduce our first virtual machine in the cloud. So this is exactly where we would be creating an account in AWS or whatever cloud you would like to, right? So I have a ready-made account in AWS, and there I will be presenting you how we can run our first virtual machine. Then we will be seeing that what are the various networking concept associated with it. And although we are not going to complete them today, but definitely from tomorrow we will be doing both of these exercises side by side. We will try to understand first the first the theoretical portion, and then we'll try to implement the same thing in the AWS cloud. But I'm not restricting you to use AWS, right? You can do this on Azure also or GCP. It's up to you. Finally, and there is a section going to be on the questions. So I'll be here for means after this session, 15-20 minutes I will be available for your questions. You can post questions during the session or after the session. It's up to you. So having said that, let's so agenda is clear, and let's have a discussion around general network design consideration. Okay. So this is a typical data center you see, right? And believe me, we are just going to shift some of the workload or maybe many of the workloads from these data centers to the cloud. That's why we need to understand how exactly the data center look. And I'm not discussing ACI, I'm not discussing the fancy things here, which are again simple, but that is not the topic of discussion in this session. But if you consider this data center, right, we have servers here and we have users here, right? And typically, what we do in a data center is we divide or segment our servers, right? For example, these servers are web servers. These should be part of one category, or these are database servers. This should come in a different category, right? Or something else, right? So how do we segment them? In current networking scenario, we segment them on the basis of subnetworks or VLANs, to be precise, right? So the intent of VLAN is if this guy sends a broadcast, it should be within only this range, right? Only within VLAN 10. And that is why basically we are not bombarding other VLANs with these broadcasts. Otherwise, everyone has to respond to these ARP queries or the broadcast, right? And that's why we call them broadcast domain also. So it is a great way to segment your network, and that's what we have done here. So consider this thing. We have VLAN 10, we have VLAN 20, and we have VLAN 30. And then we have corresponding servers into that, right? It doesn't matter where we are creating SVIs. And if you are not comfortable with them, then please just go through the videos I have mentioned in my website, and the things will be more clearer to you. Then we connect them over the switch because we are creating all these segmentation at the switch. And then we have this firewall. Why firewall? Because suppose I assign this guy as a public IP address, say 2.2.2.2, right? And this is the publicly routable range. So it is going out in the internet also. And anybody who is sitting here in the internet can access my server, right? This is very simple. But I do not want that. What I want is I want intended recipient or intended users or the authenticated users should see this. And that is where I create rules here that if somebody from this particular IP address, say x.x.x.x, wants to reach my server, right? Then basically I am making sure that the traffic path is such that, okay, let me draw the traffic path. So traffic path is such that it is going over the internet, it is coming here at the firewall and then reaching the server, right? So at this firewall, what I can do is I can create some rules, right? So suppose this is a web server, so I can specifically say that if somebody is coming for this protocol, which is called TCP, and the port 80, right, which is allocated for the web, then I should be able to permit or deny it. So what I generally do, I only permit the users or the subnets which are basically which I know are the safe, and that's why what I'm done. It is not only for the external users. It is always for the internal users also, right? Because I don't know that what is the intention of a particular person. Doesn't matter inside your organization or outside your organization. Everything is going through this firewall, right? And that is exactly where I create rules. So the important thing was I segmented my my servers. Then I have firewall where I create rules, allow access, right, or access policy rules. And then we have a router also, right? Why router? Because it is eventually connecting to internet, right? So if this server wants to go to internet, then of course maybe somebody is here which is already connected to internet, and that's why you will be seeing this traffic flow from your device, from this server to the router, again via the firewall, right? This is again simple. So this is again simple, right? So overall, if I consider, then overall, if we can consider, then the typical data center look like that we have divided into multiple VLANs. We have firewall, we have routers also, right? I forgot to mention one thing here, that suppose this is the server, right? And somebody from outside it's accessing it, right? This server. And right now the number of connections are 1,000, and you have provisioned this server for 1,000 internal connections, right? But your company is growing, and now you can expect approximately 1 lakh number of connections, right, to this server. When this happens, then there is a problem, right? So what generally you do, you spin up more servers here in this VLAN, which are offering the same service, and then you have one load balancer, right? So basically, the intention of this load balancer is you are going to have only one IP address, maybe y.y.y.y, on which every user is connecting, right? But this is the responsibility of this load balancer to route your request to different servers which are hosting the same content, right? This way, basically, this user will not be bombarded with many connections, right? It is up to you that how much you want to configure your load balancer. And why I am telling all these things, because these are the things which you will be considering in the cloud: this load balancer, this router, this firewall, and then the segmentation also, right? The other thing is, basically, generally you build your network on a private address, right? Suppose that the complete range of this network is, say, 10.10.0.0 /16. If you consider, then basically it is almost 2 to the power 16 hosts, which is kind of enough for your complete organization. And then you divide this network into multiple VLANs or whatever you want, right? The whole idea is, if anybody which is having the IP address in this range, right, wants to reach internet, then basically it cannot. And the reason is because these IP addresses, the private IP addresses, are not routable over the internet. So what you do, you generally do NAT here, right? Network address translation. And that is the guy who is just transforming your source address into the publicly routable address. Once done, then you are able to access the internet, right? The NAT type can be one-to-one, one-to-many. There is complete different theory aspects of NAT. But for now, you just try to understand, if I want to access internet from a private IP address range, then there must be somebody who is translating this private IP address range to public, right? It is as simple as that. And that is what we are going to see in the cloud also. They call it as the NAT gateway, right? And then the router, which is connected to internet, they call it as internet gateway. The load balancer is same. The firewall is almost same, right? So exactly these are the same thing which you can expect when you are trying to build your own private network into the cloud, right? As I mentioned yesterday, we will be discussing more towards infrastructure as a service, right? Where you are actually deploying your virtual machines into the cloud, and that is where you need network. And if you are creating that network, these are the constructs which you will be seeing, right? So I forgot to mention in the beginning that to begin, if you want to create any network, you need to begin with at least a network range. Right now, as I mentioned, that the complete network range of this network is 10.0.0/16, which offers you 2 to the power 16 host addresses, right? Maybe some of them will go into the broadcast or subnet part, but yes, it is still comparable to 2 to the power 16 hosts, which is a good number for your enterprise, right? So this is how actually the design considerations look for the network which we build in a data center, right? And we are going to have the same constructs there, maybe in different forms, but the intent is going to be the same. So having said that, let's discuss some of the basic concepts of the cloud, which are your regions, and availability zones. Okay. Once we cover this, then I'll come to the questions for a couple of minutes. Okay. So here, so consider cloud. It doesn't matter which one it is. This is your cloud here, right? And this one is your cloud. So generally, what these cloud guys have done is they have divided their complete network into multiple regions, right? So if you consider this one, like India, right? This is region number 1. This is region number 2, which is Singapore region. Maybe this is Australian region. This is Amsterdam or America, and then basically we have Europe, right? So in a hypothetical example, there is a cloud service provider who have partitioned its complete network into 5 different regions. And the reason behind it, that if you are in a particular region like India, then you do not need to spin your virtual machine into America region. And the reason is simple, because this portion of the network is much more closer to you with respect to America's region, right? So if you consider AWS, they have more than 22 regions. It means that they have a presence in that region. And if I say they have presence in that region, it means they have data centers in that region. And then basically they have the various construct through which you can connect into the data centers, right? So if you consider Indian region here, we have different zones. We have different zones, right? For example, in the India region, we have 3 zones, and basically AWS is predominant service provider. So I have mentioned it as the availability zone, which is a concept specific to AWS, right? But zones is the concept. So if I say availability zone, it means that basically I'm talking about AWS. So inside a particular region, I can find many zones. Maybe a region is defined if it is having more than 2 availability zones. So consider India. We have 3 zones here. What is the meaning of zone? That we can have multiple data centers into that particular zone, right? So suppose in India, we have 1 zone in Mumbai, 1 zone in Delhi, and 1 zone in Bangalore, right? And why we have 3? Because if something happens to this availability zone, it means that I have readily available availability zone 2 and availability zone 3, right? So region, and inside those regions, we have multiple data centers. And believe me, one data center is not analogous to a particular zone. A particular zone can have multiple data centers also, right? But it is important to understand that inside a region, we can have multiple zones where exactly we want to spin or run our virtual machine. So if I want to run a virtual machine, if I am in India, I will select the Indian region and then go into a specific, for example, I'm nearer to Mumbai, right? So I will be spinning up my virtual machine nearer to Mumbai availability zone, right? And we can find all this information for all the clouds like Azure, GCP into their website. And they boost their network has presence in so many places. And right now, AWS is predominant and it is having access more than anyone else. But believe me, Azure is catching them up, okay? So understanding of these 2 concepts is really, really important. Now, let's discuss your private network in cloud. So what I'm doing here is I have a company, which is, say, again, the name of the company is XYZ, right? And it has point of presence in 2 different regions, the region 1, region 2. So what I'm doing here is I'm creating my own network inside that. So I've decided that I want to deploy 6 virtual machines in region 1, right? So these are my 6 virtual machines. And then I decided that in zone 1, I will be deploying 2. In zone 2, I will be deploying 1. And then basically in zone 3, I will be having these 3, right? So where should I need to begin if I want to build this private network, this one, into a public network, which is which is the service providers network, right? So this is irrespective of the fact that there are multiple customers of AWS or Azure. It is totally private to me, right? If I want to begin deploying or developing this private network, I should begin with the number one construct which I have in my, which we should have, is I should begin with IP address range, right? What are these machines? Means how I need to segment them, right? And then basically, what is the total IP address range of my private network? And that is why I begin with this range, right? 10.10.0.0/16 is for my private network, which is in region 1. Okay. Similarly, I have decided another public address range, which is in my region 2, which is 10.20.0.0. So here, a question can come, right? Why can't we have only one private network, which extended, which could be extended into this multiple regions? And the reason behind that is, a virtual network or your network, private network, has a specific scope, right? And its scope is into a particular region. It cannot go outside this region. And they have some good reasons behind it. But if you want to understand that, then basically we need to understand how these servers are connected. Actual servers are connected in AWS, right? But I'm not saying that this is the way everybody else have implemented it. I'm pretty sure that AWS and Azure is having whatever I'm saying right now, but GCP has implemented a little bit of different, has implemented this, I think, a little bit of different flavor, right? So don't worry about it. The concepts are going to remain same. It doesn't matter how these cloud service providers have implemented it. But for now, consider that your virtual network or the private network which you are building has a scope with respect to that region only, right? So we are having two private networks. We are having these two private networks in totally two different regions, right? Now the thing comes that where I need to implement these zones, right? Sorry, where I need to implement these virtual machines. So there is a provision when I spin up a virtual machine, the cloud says which availability zone or zone you want to put your VM into. And that's why I have chosen zone 1 for these two VMs. And then for this single VM, I'm choosing this zone 2. So why I'm saying all these things, why I'm depicting all these things to you, because when we are going to create all these things in the live environment, you should relate that what I'm talking to. So region, basically their complete cloud is distributed or divided into several regions, and inside those regions, we are talking about zones. And inside that region also, we are talking about our virtual network. So if you consider that in a particular zone, what I have done is I have allocated a specific subnet out of this network, right? So what I'm doing here, and if you are not comfortable with the subnetting, I still encourage you to just go and check on the website I have mentioned in the groups, right? So there is a complete video on the subnetting itself. So here the subnetting part is simple. What I'm doing is I'm dividing this complete bigger range into multiple smaller range. So right now, if you can see that this guy is capable of having 2 to the power 16 hosts. So what I'm doing is I'm just dividing it. So this network is now having the range 2 to the power 8 hosts we can define here, or 256 hosts we can define here. Similarly here also, and similarly here. So if you can see the way I have divided, or I am configuring my virtual network, is that I have taken out a subnetwork out of my bigger network and then place it into that particular zone. So this network is attached to this zone, right? Or eventually this network is attached to my private network, and the full network is basically 10.10.0.0. Similarly here, the subnet is different for this zone, and similarly here. But it doesn't mean that you cannot have multiple subnets into a particular zone. You can have, that is perfectly fine, right? But Generally, let's keep it simple for now. What I've done is that you can have a single subnet associated for a particular zone, right? So when you do that, then basically you have, so this is how your virtual network looks like, right? So in AWS terminology, we call this private network as virtual private cloud or VPC, right? In Azure, we call that as virtual network, which is nothing, but the concept is same. This is your own private network inside cloud. Similarly, you can create another VPC or VN, right, inside the region 2. And believe me, these two networks are totally isolated. So if you do not do anything, then this guy is not able to communicate with this guy, right? And that is where basically some of the concepts come into picture. So you would like to do a peering between them, right? You need to connect your two virtual networks between them, right? And this is what we call the VPC peering. So that is fine. So what I would like to do now is we will go a little bit deeper into this so that we can understand. So suppose if this virtual machine wants to talk to this virtual machine, then what is the traffic path that it's going to take? Or when this virtual machine just want to go out and reach to internet, what are the various constructs we can have? What are the various virtual things in the cloud which we can deploy? Or the same thing, basically, if these two virtual machines are hosting the same thing, then I need to load balance the traffic across them. So is there any construct with respect to them? Then firewall also, right? If I want to restrict the traffic movement between these three zones, or basically between two different VPCs also, is there a firewall construct? Okay, so let's look slightly deeper into our region 1 and then basically our virtual network. Okay, having said that, I would like to take some questions because I could see there are a lot of things coming to Punish. Punish, can you guide me with the questions?
Looks like a lot of questions. So
wow. So we will take few, maybe 2, 3, which you think that are the important one, and without which we cannot proceed, and then we can proceed and take the remaining questions at the end.
Sure. Yep. So this is one from Utkarsh. Can we have same subnet span across different availability zone within a region?
Yeah, this is the way how basically cloud is implemented. So I could see that in GCP, but AWS and Azure, in AWS Azure, you cannot do that. Your VPC or your virtual network is of that basically same region scope. So you cannot expand this network into the region 2 networks. Okay, but I'm not saying that this is the case with all the cloud. It is up to the implementation details of a particular cloud. But it's a good question. Yes, Punish.
Yep. So can we do VPC and VNet peering?
VPC and VNet peering. What is VNet? Basically, if you're talking about AWS, then basically we are talking about only VPC, right? Do not
Yep. So that's
confuse the terms. Yeah. Go ahead.
So can we do like VPC AWS and VNet Azure peering?
Now your question is basically you want to peer between two clouds, right? So there are other options. Just like when we connect this cloud with our enterprise, there are options. We will be discussing that. Don't worry about it. But yes, there are options. Yeah, Punish, go ahead.
Yep. So can we have multiple VN VPC in a region for an organization?
Multiple VN VPC. Yes, definitely. So I'm not saying that you can have only one VPC in a particular region, right? You can have multiple depending on your needs. But yes, one VPC, basically, if I talk about Azure, cannot is only restricted to that region only. But you can have multiple VPC into that. Anything else?
Yes, so this one we can take. Can we have like 10.10.00/24 subnet in different regions?
No. This should be uniquely identified. Why do you want to come up with the overlapping subnet range if you have so much, right? Private address ranges, it's a bigger range. You'd never want. Otherwise, if you do the same range, then basically you need to do so many things here. Maybe you need to include a NAT device which is transforming your IP address. So suppose if you have the same network range here, you have the same network range here, and you want them to be able to communicate at a later point of time. You cannot do that, right? Unless you specify something. I'm not saying that it is not possible at all. It is, but you need to. You don't want to do that. So we'll take further questions after some time, Punish.
Yep.
Let's complete the fourth one, which is going to be the interesting thing. Yeah, this is the one, right? So what we are doing here, guys, is I am just concentrating on a particular private network, which you call the VPC, and then see what exactly inside that VPC, what exactly your VPC load, right? So this is your private virtual private network or virtual private cloud. This one, the complete, right? It's simple. Now what you have decided is you have come up with a IP address range, which is 10.10.0.0/16, and you have decided that I will create this network out of this network range. So this is kind of my supernet, you can say, right? 10.10.0.0. Now you have decided that I want my web servers to be in a particular subnet, and then my database servers should be in a particular subnet, right? So what you have done is you have defined here two subnetworks, 10.10.10.0/24 and 10.10.20.0/24, and then basically you have allocated the IP address from this range. So this may be .10. So what is the meaning of .10? That the IP address of VM1 is 10.10.10.10. Similarly here 20, similarly here 10, similarly here 20, right? So the important thing is that you are considering these two subnets, right? And it might be part of the same availability zone or different availability zone, doesn't matter, right? But sometimes what generally we do is that we deploy one VM in a particular availability zone and its replica or its backup in the different availability zone, and you can self figure out the reason, because if something happens to a particular availability zone or particular data centers in that zone, we are going to still have the other part, right? So this is the thing. But how now I have defined these VMs. So how these VMs communicate, right, inside a particular VPC. So when you define this VPC, there is a by default route table or the route table created in the VPC itself, and we call that as main VPC route table. Terms are different, but believe me, guys, this is nothing but a simple router, right? And inside that router, you will be having a static route, which is 10.10.0.0/16 via local. What is that route? This is the route from which you have begun configuring your VPC. So it means that when we are clearing your own network in the cloud, you need to say to the cloud that this is the IP address range which I want to work with. And that is exactly where the cloud routers say that, okay, this is the local range. And if any VM in that particular range wants to talk to any other device into that particular region, then basically I know that this is my local range, so I can locally pass the traffic between them, right? So consider this. If this guy wants to talk to this guy, or this guy wants to talk to this guy, then basically consider that here we have a router, right? Which is mentioned by this route table. So the traffic flow is going to be very simple. First, that suppose VM1 wants to talk to VM3. VM3 is in the different subnet, and then basically it is go and check its routing table, which is this one. So every private cloud or the VPC you create comes with this routing table. And if you haven't done anything custom with respect to routing, this VM is going to consult this router, which is eventually, and consider the route table for this router is here, right? It will consult this router, maybe say R1, and you cannot see this router there, right? Because this is a virtual construct. But believe me, you can create routers there like Internet Gateway, and which is going to be visible just like your virtual machine, right? But this is inherent because VMs want to talk to another VMs which are in the same logical construct. So when VM1 wants to talk to VM3 here, right? VM1 will go to the router 1, which consult its route table, and here is its route table, which says that if you are going anywhere within 10.10.0.0 range, you just need to do that path locally. Locally means it is available with you, and then basically this router knows that where to reach this VM3. It's very simple. It is as good as basically you have created two VLANs and then connected that to a router, and that is why the understanding of this board is really important, because at the end of the day, it is nothing. It is again CCNA level networking, but yes, you need to have an overall picture of this thing, right? So if you understand this, believe me, cloud networking is just simple. So the traffic flow between the VMs inside a particular VPC is very simple. If this guy, VM1 wants to talk to VM3, it needs to consult its main routing table, which comes as a part of that VPC, right? When you define that network. And once you define that network, basically it says 10.10.0.0/16. Any host inside that range could be reached locally, right? Now consider the second traffic path. What if these VMs wants to talk to this internet gateway? Sorry, to the internet. Now what I'm saying is that suppose this guy here, VM1, wants to reach to some server which is attached to internet, right? And everything is in the cloud. So there is a construct in the cloud which you can create, and if you don't create that, then basically you are not able to reach to internet. Although there are defaults are available, but if you have created your own virtual network inside the cloud, then you need to create this internet gateway and attach this internet gateway to your network, right? It is as simple as that. You have your data center network. Now you want to reach out to the internet. You need to have something which is connecting your data center to internet. And this guy in cloud is doing that. Again, virtual construct, you need to just, and basically it's kind of a service, you can say, that you can have this internet gateway. Once this is there, once you have this virtual construct, just connect it with this routing table, or just connect it with this router. Okay, let me remove that, because that is nothing but a simple routing table, which is routing table of what router? This router, correct? So now, as soon as you connect internet gateway to this this router, how the routing table get affected? The routing table will say that along with the local route, now you have the default route also 0.0.0.0. And if you want to reach out to anything which is not matching this, just go out of internet gateway. So 0.0.0.0/0, which specify everything should reachable via internet gateway. It's as simple as that, right? So what actually happens? So suppose this VM wants to talk to this server here in the internet. Let's draw the traffic path. Again, very simple. So this will go and search into the local VPC routing table, which is by default there, right? And now it will check that now I do not want, and suppose the IP address of this server here is maybe say 4. Okay, bad. Suppose 4.4.4.4, right? And then it will look into this routing table here that it is not matching my local route, it is matching the default route. And then it says that yes, you can reach it via the internet gateway. And then basically internet gateway, which is again a virtual construct. And then your cloud is connected to internet, and then you can go and come back, right? It is simple. Now the important part is how the IP address of this VM, this particular VM, if I draw it here looks like, right? This VM. So basically this IP address means if you choose default everything, then this VM is configured with two IP addresses. One, which is a public IP address, and the other IP address is the private IP address. This private IP address range is nothing but the IP address which this host or the VM get from this private range which you assign to it. For example, for this VM1, the IP address, the private IP address will be 10.10.10.10, right? /24. But the public IP address range, or the public IP address is going to be the one which is allocated by the Amazon or Azure to you. Maybe it is 3.1.1.1, right? So if somebody from here, from y.y.y.y initiate a connection, then he will be, he wants to talk to this guy because this is the publicly routable IP address, right? Concepts are similar, concepts are same. So if you are talking out from a virtual machine towards an internet, then you must be having somewhere a public address, right? Or there must be somebody who is translating your address. So I haven't touched this concept of NAT gateway, which we are going to, but for now, understand that basically if this VM1 is able to reach the server without doing anything, it means that this VM1 is having the public address. Okay, I think things are making sense, right? Now, let's consider another scenario because I want to cover all these things. Okay, so now, what happens that it is imperative that these web servers, right, would like to talk to internet, but sometimes the databases which are where I used to store my data don't need to be on the internet, right? So, but the problem is by default, this VM3 will, means if we have a setup like this, right? By default, the VM3 will look into its routing table, the default routing table, which comes with your private cloud, and then send everything to this thing, right? It means that the problem is, means if I always follow the route table, then I cannot control this, that which subnet, basically, which subnet should go out of the internet and which should not, right? So there is a simple thing that you can create your own route table at a subnet level, right? So you can have your own router here. When you create this own router here, its routing table by default will be looking like this, that 10.10.0.0/16 should be reached locally, which is the by default thing, right? But if you attach this router with internet gateway, then basically you will be having this thing also, 0.0.0.0/0 should be reachable via iNet gateway. In this case, basically the traffic flow will be simple, VM will go like this, right? But if you consider VM3, and if you have created a router for or route table for this guy also, for this subnet also, and you haven't connected this router to internet gateway, this wire is not there at all, right? It means that this subnet routing table will only have this route 10.10.0.0/16 and no default route because it is not connected to iNet gateway, right? Which simply means that this VM3 cannot go and reach out to internet. But yes, VM3 can still manage to reach out to VM1 because I have permitted this thing, because this routing entry is already there, right? So it will go like this, VM2 or VM3. And if you have local routing table attached to a subnet, then believe me, it is not going to consult the main routing table because you have created its own local routing table, right? Okay. So now, what if, again, the question that, let me unclutter this first, right? So suppose I have created a route table here, means a router here, which is only having locally routes, right? Means 10.10.0.0/16, right? And now after some time, I feel that this VM3 also needs to go out of the internet, right? Then definitely means I do not want to talk to this guy, right? Otherwise it will be because I have created my own routing table. So what I can do here is, and now I can say, and I do not want to assign any public IP address to my VM. So there is only private address. Amazon hasn't assigned the public address range here, right? So suppose it contains only this address. Say this is, I believe this was 10.10. Okay, 10.10.20.1. Right? This is a private address, and if it wants to talk to internet, and I do not have any public IP address, so what I can do here is I can spin up another router, which we say NAT gateway inside the cloud. Connect my local router to this guy. NAT will be connected to internet, and then basically I will be able to reach out to internet. And when you connect it to NAT gateway, there is a automatically route install, which is 0.0.0.0/0, and you should go and reach out for such addresses through the NAT gateway. If this thing doesn't make sense, no worries. We will be repeating it in tomorrow's sessions also. But right now, we have understood few things, that whenever we have a VPC or when we create a virtual private network, we need to select an IP address range, right? That IP address range will directly go into its main routing table, which the router which is attached to this VPC or your private cloud, right? And inside that VPC, we can create multiple subnets across multiple availability zone or a single availability zone. Once we do that, then basically all subnets or all VMs are going to consult everything to this route table, which is the default route table or the main route table. But we do not need to be dependent on that, and that's why we can create our own routing tables per subnet, right? Once we do that, then basically all these VMs into this subnet are going to consult with this router and not the main router. And there are significant advantage of doing this, right? And this is nothing, guys. We are already doing all these things in the normal routing, right? Suppose we have a switch in the data center. We have created multiple VLANs, right? VLAN 10, 20, 30, and then we created multiple SVIs here. So if anybody wants to talk to them, they must come to this SVI and communicate between them. Exactly same thing, but the implementation is different, right? We do not have any switch there, but we believe that whatever they have implemented, there must be some switch. And I will be explaining you exactly how to VMs talk in a particular server level also, but that is slightly off topic. And that's why we are going to take it at the end of the session, means at the end of all the sessions. So having said that, basically these are the things which I want to showcase to you in today's session before moving to the actual practical lab, right? But right now, if you have the firm understanding of all these concepts, then you are good with respect to creating your own virtual private network in the cloud. I'm not saying that you are fully proficient, because you can create on your own virtual private network, but how are you going to connect this back to your enterprise or to different virtual network or some other customer, or basically different virtual network of basic in another region for you, right, for your enterprise. So we will be discussing that, but for right now, for 2 or 3 minutes, I would like to take questions. Punish, do we have any question now?
Yes.
Just 2 or 3, and then we will do the demo.
Okay. So that's what our request from VM1 will still exist in this, or some other protocol?
Actually, the basic construct, the address resolution protocol is always, means they are not going to go anywhere, right? Whatever the new networking terminologies are coming, they are just utilizing that or improving how we can handle our, right? That is again at the server level, but that networking is really, really interesting. So that's what I said. Just leave that part for now. Just concentrate on right now that how things are working on a VPC level. But yes, I can understand that there is a problem, that because people doesn't know what actually happened underlying in the actual server. So we will be covering that on the last session. But believe me, that is the whole sort different approach of networking. So because there we can talk about different solutions like VXLAN, NSX, and whatnot. Maybe ACI also, which we are utilizing some of the concepts from there. So Don't worry, means we will be covering if time permits in the last session. Otherwise, we can talk offline about it. Yeah, Punish.
Yep. So this so now, what do you what do you exactly mean by construct?
What do you so basically, if I say that yeah, so the board is already here. If I say that Amazon provide me this iNet gateway, then I mean to say that this is a networking construct which Amazon is providing me, right? This NAT gateway is the another construct. Okay, this route table is the another construct which I can create. Okay, I think things are making sense. Okay, Punish, go ahead.
Yep. So Raj, how fast is cloud route table because it doesn't use the TCAM memory?
Means I'm not sure about it, that how they are implementing, but yes, these are pretty fast. Means I don't see any problem with respect to these route tables because these are running on the powerful machines, right? I agree that basically it must be utilizing the TLOC, but see the how efficient the routing is, right? You are the subnet, means you have multiple subnets here, and then if you want to advertise this complete thing, then basically you can advertise with a single statement. So I agree that it depends on TCAM, but if you have efficient routing, which is there in the cloud or the network, basically you do not need much space. But if it is, means you are not doing the efficient routing also, then still these are the very powerful machine on which these constructs are running. Yeah, Punish.
Yep. This from Meghna that's for availability. We generally have deployed services in multiple AZs within a region. For this, can the subnet span across the AZs, or it would be different subnet of the main
subnet
network?
can span across the AZs.
Okay.
So let's complete this exercise first, right, Punish? Let's spin our first virtual machine in AWS. So what we can do, guys, is basically there is availability of free tier account for all of us, right? You just need to have your email ID. Just go into the AWS console and create an account for your own, right? Once you are done, then just make sure that you enable some billing things also, because by mistake, if you have chosen a very hi-fi machine, right, with a configuration which requires a lot of money, then basically you will be charged for that. So choose free tier account, and once you are there, then basically there are everything. For example, if I go here, so how do I want to spin my first virtual machine there? So there is a service which is called Elastic Compute. Why Elastic? Because you can increase, decrease the memory and hard disk and everything, right? So this is the service basically. And when you come here, then simply what I'm doing here is I'm just launching my first instance or virtual machine into the cloud, right? I'm not talking about the VPC and all. Everything is default till now, right? I'm not doing anything. But yes, believe me, from tomorrow onwards, once you see the recordings, or if you want to get comfortable with all these concepts, once you have all these concepts in your pocket, then we can definitely, we will create our own VPCs, our own gateways and whatnot. So if you can see that on top side here, right, I am right now in the Mumbai region. So if you consider that Amazon has so many regions here, right, in US, Asia Pac. So I have chosen this one, my own region. I am in Mumbai region, and what I want to do is I want to say, they are saying that which operating system or the hardware you want to. So just look for these, right? Free tier eligible. So we are having multiple free tier eligible devices here. Let me select this one. Maybe you can select anything. So it is saying now that this is your virtual machine, which is going to have only one virtual CPU. Memory is again 1, right? 1 GB. And then basically it starts at configure instance. So right now, basically, if you can see here, we are defining network. Network is nothing but your VPC, and by default in every region they have one VPC configured, right? So everything is by default till now, because I don't want to bombard you with a lot of configuration when you are seeing this screen is the first time, or maybe first time. And then basically we have availability zone, that inside India, basically we have these availability zone inside Mumbai also, you can say. And then what are the IP address you want to assign, whatever the things. So these are the various things which you need to give, then host name type and whatnot. Then add storage. I'm choosing the default storage of 8 GB. Then tags. I'll let you know what tags do. Configure security group means, see, once you have done this, you have, and we will be learning about, because I haven't mentioned about firewall or security groups right now, which we are going to discuss in tomorrow's session, right? So I have chosen default, means anybody who is coming and making a SSH connection to this machine with this protocol TCP, then I will be permitting it. And this is how my virtual machine looks. And then I just say launch here. And when I do a launch here, so basically you only want to access this machine, and that's why they generate a key pair, which is public and private key pair. And then you need to have this private key pair file with you when you want to. And this is very simple concepts of networking, network security. If you do not know about them, then please do the 5th recording of SD-WAN session, and you will be pretty much clear about this. And all those recordings are placed already in the website which we have created. Okay, so I have chosen my own key pair, then launch instance. Right. Once you do that, basically you can see here that here is the instance which is coming, and it is still in the pending state. So how you are going to connect to it, right? So let me refresh it, and maybe you will be seeing that it is running now. Yeah, you can see that this is running now. And now if you do, and here are some of the properties which we have discussed. This is the public IP address, which is allocated by Amazon, right? This is the private IP address, private IP DNS name, which is only for, and what is the private IP address range, which is this one, right? And then if you do a connect, it will show you through what parameters you can connect. It's a simple statement. You need to do SSH to this publicly available host, which is EC2, this one, and the username is Ubuntu. So I copy it, and then I have secure CRT here, sessions manager, AWS, then I change the properties of it, and maybe, yes, let me check with that, whether I'm using the correct name or not. Me session manager, and then we are going to create a new one. New session. And in this new session, I'll put the host name as this one. And then username is Ubuntu. And then the password is going to be public key. Here one. And the properties is this one. Okay, fine. Okay, yeah, I could see that. And then basically I could see this. So if you do a ifconfig here, I am into the server. So why I have spin the server? Because we will be playing a lot with this in upcoming sessions, because we need to create our own VPC and all. So having said that, Punish, I would like to take some questions if there are any. Punish, we have so many, means much questions, or we can go with the quiz.
We have few questions.
Yeah, let's answer them first.
So okay.
Punish, little faster.
Okay.
Yeah.
So let's. This one is from Kapil. Can two different customers use same public IP address space in a single availability zone?
Yes, they can use. There is a separate mechanism for that.
Okay, so the same question is, if yes, how do we providers separate?
Yeah, that's a provider network. Basically, everything is running on MPLS, and we can discuss about it, Kapil. Don't worry.
Okay.
Yeah.
And this from Akshita. So these NAT gateway, INET gateway, the virtual constructs are basically just VMs with modules coded to the.
I'm not sure how they have implemented, but yes, those are somewhere running in the cloud. This is not clear. What exactly the question is, Punish?
So in this scenario of local and global VPC routing table, how would we know about the exit interface or next hop? To say,
Okay, you need to, so basically if you are going local, you do not need to. This local is an interface, right? And if you want to talk to internet gateway, then you need to specify here. You need to connect this. When you connect this, you will be having the default gateway here. Yes, another question? Manish?
I think it's not sure if it's answered. It's how we segregate different customers having same private IP range in same region.
Yeah, the concept is going to be same. Underlying MPLS is running and there. So that's a totally different question, not related to this. Yeah, but we can discuss it. Yeah.